G'day, my name's Kyle. My group's going to be explaining how to use the AIP to derive the transition layer from any given QNH.
So departing from your local aerodrome, first set your local QNH. If the local QNH is unavailable, you can set your area QNH. If we're climbing up above the transition layer, which in Australia is always 10,000 feet, it's important to set the QNH to 1013. That ensures that everyone who's cruising above the transition layer is all measuring their altitude off the same pressure datum. Once we get above 10,000 feet, we convert to what's known as flight levels, and that's essentially altitudes within hundreds of feet. So if we're cruising above the transition layer and the QNH is below 1013, flight level 110 isn't available for the cruise. If it's below 997, flight level 115 isn't available. Below 980, flight level 120 isn't available. And below 963, flight level 125 isn't available for cruising. So have that in mind.
Yeah. So when descending from your flight level, the flight level that is unavailable due to area QNH becomes the top of the transition layer, and when passing through that flight level, you set local QNH, or if unavailable, set area, and continue your descent till at least your altimeter reads 10,000 feet, because above 10,000 feet is not available due to the transition layer.
Alright, so while you're on the ground at your departure aerodrome, if you can't obtain the local QNH, you can find it by setting the aerodrome elevation on your altimeter and reading the subscale, which will give you your local QNH. So on a G1000 Cessna 172 like we have here at RMIT, to set the local QNH, or to find it, first you go to the barrow knob here, which is the big one, and then you twist it until it reads the elevation of the aerodrome. So at Point Cook that would be 14 feet that it would be reading here. And then you read down here, and in HPA it will have the QNH, the local QNH.
Alright, so when you're on the ground, but you set the incorrect altimeter to read a higher number, you're going to end up being 30 feet for every 1 hectopascal below. But then once you climb up, you're going to be flying at 5,030 feet when you're designated an altitude of 5,000 feet. This is called overreading. So if you were to now set the altimeter to a QNH of 1012, which is 1 hectopascal more, it's going to read 30 feet high. But then when you climb up to 4,970 feet, your altimeter is then going to make you read 5,000 feet, and this is called underreading. So to calculate height error, we take the actual QNH minus the set QNH on the altimeter times 30 to get our height error. An example of this is an overreading altimeter where the actual QNH is 1013, but you accidentally set 998 times 30, and that's going to make you overread by 450 feet. Otherwise, with an underreading altimeter, where the actual QNH is still 1013, but you set 1023 times 30, that's going to make 300 feet that the altimeter will be underreading.